For decades, Cummins has been synonymous with diesel engines. These powerful workhorses dominate the heavy-duty vehicle and equipment industries. But now Cummins is making a bold move. The company is shifting its focus to hydrogen, a clean energy source that could revolutionize transportation. This is a significant change for Cummins and the entire industry. It signals a future where clean energy powers our biggest machines. Cummins' decision is driven by a growing need for sustainable solutions. Diesel engines, while powerful, are notorious for their environmental impact. They release harmful pollutants into the atmosphere, contributing to climate change and air pollution. The world is searching for cleaner alternatives, and hydrogen has emerged as a promising contender. This shift is not just about environmental responsibility, it's also a strategic business decision. Cummins recognizes the global push towards decarbonization. Governments and industries worldwide are setting ambitious targets to reduce emissions. By investing in hydrogen technology, Cummins is positioning itself at the forefront of this clean energy revolution. The company aims to lead the charge in developing and deploying hydrogen-powered solutions for a more sustainable future. This is a story about innovation, sustainability, and the transformation of an industry. It's about a company embracing change and paving the way for a cleaner, greener future. Diesel engines have long been the workhorses of heavy-duty transportation and industry. Their power and efficiency have made them indispensable for trucks, buses, construction equipment, and more. These engines, however, come at a cost. Diesel engines are major contributors to air pollution. They release harmful pollutants, including nitrogen oxides, particulate matter, and greenhouse gases like carbon dioxide. Nitrogen oxides emissions contribute to smog and respiratory problems, while particulate matter can penetrate deep into our lungs, causing serious health issues. Carbon dioxide, on the other hand, is a major driver of climate change, trapping heat in the atmosphere and leading to global warming. The environmental impact of diesel engines has prompted stricter regulations and a search for cleaner alternatives. Governments around the world are implementing stringent emission standards for heavy-duty vehicles. In some regions, like California, there are plans to phase out diesel trucks altogether in the coming decades. The writing is on the wall. The era of diesel dominance is coming to an end. This environmental imperative, coupled with the need for energy security and technological advancement, has fueled the search for a cleaner, more sustainable solution. Enter hydrogen, a fuel source with the potential to revolutionize the way we power our world. Hydrogen is the most abundant element in the universe, and it holds immense potential as a clean energy source. Unlike diesel, which releases harmful pollutants when burned, hydrogen produces only water vapor as a byproduct. This makes it a zero-emission fuel, offering a pathway to decarbonize heavy-duty transportation and other industries. Hydrogen can be produced from various sources, including natural gas, renewable energy sources like wind and solar power, and even biomass. When produced from renewable sources, hydrogen becomes a truly sustainable fuel option, closing the loop on carbon emissions. The use of hydrogen as a fuel is not a new concept. However, advancements in technology and a growing urgency to address climate change have pushed hydrogen to the forefront of the clean energy transition. Cummins' investment in hydrogen engine technology is a testament to this shift, signaling a future where clean energy powers our biggest and most demanding machines. Cummins is not simply dipping its toes into the hydrogen waters, it's diving in headfirst. The company is developing a range of hydrogen internal combustion engines designed to replace their diesel counterparts in heavy-duty applications. These engines utilize a proven technology, internal combustion, but with a clean energy twist. Instead of diesel, Cummins' hydrogen internal combustion engines run on hydrogen gas. The hydrogen is stored in high-pressure tanks and fed into the engine's combustion chamber, where it mixes with air. A spark ignites the mixture, creating a powerful explosion that drives the pistons and generates power. This process is similar to how a gasoline engine works, but with one crucial difference. The only byproduct of hydrogen combustion is water vapor. This means Cummins' hydrogen internal combustion engines can deliver the power and performance of their diesel counterparts without the harmful emissions. Section 5. Power and Performance: Hydrogen versus Diesel. One of the most common concerns about alternative fuel vehicles is their performance compared to traditional gasoline or diesel engines. However, Cummins' hydrogen engines are designed to match and even exceed the capabilities of their diesel counterparts. Early tests of Cummins' hydrogen engines have shown impressive results. These engines can deliver over 500 horsepower and 1,200 newton meters of torque, rivaling the power output of many diesel engines used in heavy-duty applications. Furthermore, Cummins aims for its H2ICE to have the same durability and reliability as their diesel engines, ensuring they can withstand the demands of heavy-duty use. Another advantage of Cummins hydrogen engines is their compatibility with existing vehicle architectures. The company has designed its H2ICE to fit into the same space as their diesel engines, minimizing the need for costly redesigns. This means that transitioning to hydrogen power could be a relatively seamless process for fleet owners. Section 6: Collaboration and Innovation, the Path to a Hydrogen Future. Cummins recognizes that the transition to a hydrogen-powered future requires collaboration and innovation across industries. The company has forged strategic partnerships to accelerate the development and deployment of its hydrogen engine technology. One such partnership is with Linde, the global leader in industrial gases and engineering. Together, Cummins and Linde are working to establish a robust hydrogen production and distribution infrastructure. This includes the development of electrolyzer plants that produce green hydrogen using renewable energy sources. Cummins is also actively involved in research and development projects to further enhance its hydrogen engine technology. The company is exploring new materials and designs to improve engine efficiency and durability. Additionally, Cummins is working on optimizing hydrogen storage systems to increase vehicle range and reduce refueling time. Section 7: Government Backing, Fueling the Hydrogen Revolution. The transition to a hydrogen economy requires significant investment and support, and governments around the world are recognizing the importance of this clean energy source. Policymakers are implementing incentives and funding programs to accelerate the development and adoption of hydrogen technologies. In the United States, the Department of Energy has launched a Hydrogen and Fuel Cell Technologies Office to support research, development, and deployment of hydrogen energy technologies. The recently passed Infrastructure Investment and Jobs Act includes billions of dollars in funding for hydrogen infrastructure, including the development of regional clean hydrogen hubs. These government initiatives are providing a crucial tailwind for companies like Cummins that are investing in hydrogen technology. By providing funding and creating a supportive regulatory environment, governments are helping to make hydrogen a viable and competitive fuel source for the future. Section 8: The Road Ahead, Challenges and Opportunities. While the future of hydrogen looks promising, several challenges must be addressed to realize its full potential. One of the biggest hurdles is the cost of hydrogen production. Currently, most hydrogen is produced from natural gas, a process that still generates greenhouse gas emissions. To make hydrogen a truly sustainable fuel source, it needs to be produced from renewable sources like wind and solar power. However, green hydrogen production is currently more expensive than traditional methods. Further technological advancements and economies of scale are needed to bring down the cost of green hydrogen. Another challenge is the lack of infrastructure. A widespread network of hydrogen refueling stations is essential for the adoption of hydrogen-powered vehicles. Building this infrastructure will require significant investment and coordination between governments, energy companies, and automakers. Despite these challenges, the opportunities presented by hydrogen are too significant to ignore. As Cummins and other companies continue to innovate and invest in this clean energy source, hydrogen has the potential to revolutionize the transportation industry and pave the way for a more sustainable future. Section 9: Cummins driving towards a sustainable future. Cummins' decision to embrace hydrogen is a bold and necessary step towards a cleaner, more sustainable future. The company's commitment to developing and deploying hydrogen engine technology demonstrates its leadership in the clean energy transition. By leveraging its expertise in engine design and manufacturing, Cummins is well positioned to drive the adoption of hydrogen power in heavy-duty applications. The company's hydrogen engines offer a compelling combination of power, performance, and environmental benefits, making them a viable alternative to traditional diesel engines. As the world moves towards a low-carbon future, Cummins is setting an example for other companies to follow. By embracing innovation and collaboration, Cummins is helping to create a future where clean energy powers our world and preserves our planet for generations to come.